I would also like to welcome you to the WGIC GeoAI Virtual Conference. As Harsh said, I'm Jim Steiner. I'm Vice President at Oracle. I'm responsible for our spatial technologies. I'm a member of the WGIC Executive Committee and one of the members of the WGIC Policy Committee. And I've been asked to say a few words about the WGIC Policy Committee and the ongoing Geospatial AI/ML policy study that we have. The WGIC Policy Committee was established to research and document relevant policy areas affecting the geospatial industry. We do this along with stakeholders in academia, industry, public sector, and civil society. Each year, the Policy Committee selects an area or two affecting the geospatial community to help us better understand how to address policies, technologies, and other important developments in the market. In 2019, we focused on data privacy and geospatial information. WGIC produced a paper on geospatial information privacy policy and shared the findings and recommendations through a series of webinars and roundtable meetings. I'd like to encourage all of you to download this policy paper from the WGIC website when you get a chance. Over the last few years, we've experienced the rapid growth of artificial intelligence and machine learning applications. AI/ML technology offers the promise to address problems thought to be previously unsolvable for many geospatial applications and technologies. But as with all innovations, there can be issues that we need to look at and address. Things like privacy, intellectual property, fairness, diversity, and inclusion, and the possibility of implicit bias that public authorities may need to address. The WGIC Policy Committee wants to strengthen the public debate toward developing effective and balanced AI/ML policy. And we want to help form policies that will enable the geospatial industry to maximize the benefits of these new technologies and ensure that they're used in a manner that has a positive impact on society. The first phase of our work is to develop a body of knowledge on the ways in which AI/ML is being used in the geospatial industry and what policies have been formed and are under development to address the use of AI/ML. To this end, we've engaged a consultant, Mr. Lokendra Chauhan, working with the distinguished professor, Dr. Shashi Shekhar of the University of Minnesota as an advisor, to direct research into this area and interview stakeholders representing industry, computer science, government, academia, and thought leaders. A number of you in the audience and panelists have participated in this, and we appreciate your help. The findings of this research will address areas ranging from how AI/ML will be applied to geospatial workflows and technologies, to ethical and societal challenges that may arise from the use of these technologies, to the regulatory and legal environment to which AI/ML-based solutions may have to conform. The outcome of this research will be shared in early 2021 it says roundtables, but it's probably going to be virtual roundtables and webinars with relevant stakeholders to further define recommendations as well as practices and guidelines for the geospatial industry. Which leads me to today's virtual conference. Over the next 3 days, we will hear from experts in the geospatial world about some exciting new AI/ML-based applications and on many, if not all, of the topics I've talked about. We're fortunate to have many of the most distinguished thought leaders representing technology and solution providers, international and government agencies, and academia as panelists who will share their knowledge and experience. I'd like to thank them all for sharing their valuable time and wisdom with us. And this is where I would ordinarily ask for a round of applause, but I guess I'm not sure what the virtual equivalent might be. So I will extend our thanks on behalf of WGIC and all of the attendees. And with that, let me pass this on to Harsha to start the day. Thanks very much.
Thank you very much, Jim. As Jim has mentioned, we have these WGIC members and partner organizations supporting this event, and we thank all of them.
Excellent, thank you. All right, so thanks. Hello, everyone. Thanks for the introduction. So I'm Benoit Fredericque from Bentley System, and I'm leader of product management for reality modeling and geospatial technology. And this includes several of our, we say, more exciting initiatives that touch AI. My presentation today will be in the context of digital twin. And the reason is because I think it's one of the most significant trends that we can see in the industry today that take benefits of other trends such as reality modeling, mapping, AI, IoT, and several other technology that are emerging. So just to set the stage properly and make sure we share the same understanding of what is a digital twin, let me just reintroduce the definition of at least the way we Bentley see digital twin as a digital representation of the real world of the physical asset, process, and system, including engineering information, with the goal to have a better management and control of the performance of the different assets. So it's really about making a clone, not only of the assets in the virtual world, but also of the process and the system that comes with the asset. And the asset here must be thought in a relatively wide concept. It can be a city, it can be a road network, and different scale. So in no way digital twin should be limited to a view where, for example, it apply only to factory or within building. So as I mentioned earlier, I think it's really a big trend in the industry. It's the next digitalization step. And we look at geospatial technology, reality modeling, and AI as a key enabler for digital twins. So what I like to do is maybe start with some example to also illustrate the way we look at the market and the big trends in the industry. And in that example here, what you see is actually a 3D city model of the city of Muscat that was done only with drone surveys within 19 days. It's the winner of the Year in Infrastructure Award of this year. And the point I want to make here is, as a big trend in the industry, we see that the drone and the technology to map the world, to do reality modeling, reality mesh are just accelerating and increasing drastically the resolution. And so here, just a very impressive illustration of that model. I think the overall trend applies to the quantity of data that can be acquired by drone, but also by mobile mapping system like that, or other type of device such as iPhone and handheld device that enables acquiring more and more data. More and more data everywhere at higher frequency to feed the digital twin about what is happening on the real world. So the digital representation, the digital twin is on sync. So the takeaway that I want to stress here is that what we witness with those trends is an increase of the quantity of information at the speed of acquisition, the density, the resolution, leading to a tremendous opportunity, but also to a big need in terms of analysis of that data, a big need for automation. And that's where AI is definitely an enabler. So here, I just want to share some example where we applied AI to city, to geospatial information. In that context, it was a project with the city of Nice in the south of France, and AI was used to process the 3D city model and the imagery in order to tackle different use cases, 3 use cases here. One of them was the automatic inventory of palm trees, because these species is actually suffering some disease and need some extra care. The automatically mapping of solar panels due to the tax aspect, and also due to the connectivity to the electricity network and the grid. And another aspect was just to, let's say, automate the extraction of ground. So for that, the user worked with us on some AI technology under the product name Context Capture Insights. And the 2 stages, typically about training the AI and running the AI, were applied to the datasets. And looking at the palm trees the area on the city where we can find the palm trees are quite limited. It's 2 square kilometers, but using AI, they were able to detect 280 palm trees. On the solar panel, the work was relatively limited to only 5 days for one technician, and all the coverage then was able to be processed to map automatically the solar panels. And then for the ground, same story. Some labeling made with some existing GIS data to train the AI, and then the process was run on the city data set. So if you want to know more about that use case, there is a dedicated session that you can find online at this address. And just before finishing, just wanted to give some other insights about how that kind of technology can be used these days. We use that also at very close range scales. Remember at the beginning of the presentation, I mentioned the diversity of the type of data that comes from aerial mapping to ground-based with, let's say, technician using their iPhone. And here it's an example of a bridge that was modeled by automatic photogrammetry, and where we used actually AI to automatically detect the status of the bridge and detect cracks to enable an automatic reporting and analysis of the crack. So here, just to finalize, just a quick example of that model made automatically from photogrammetry. And what you can see on that bridge, highlighted in blue, was all the defects that were automatically detected, using the AI technology applied to those pictures. And I think that's the end of my 7-minute presentation. I hope it triggered some interest, and will be more than happy to answer questions later on. Thank you.
So hello, everyone. I'm very excited to be with you today. My name is Omar. I'm the Director of AI and Machine Learning in Esri, and I want to walk you through how do we perceive this interesting intersection between geo and AI, and what are the different use cases as my colleagues are doing. So this is the way we see AI, machine learning, deep learning. AI is the big idea of achieving human-level intelligence. Machine learning is one field of AI that's about learning from data to derive rules and extract patterns instead of being explicitly programmed. And deep learning is one type of AI, one type of machine learning that's using deep neural networks. And it's becoming recently very good at dealing with high-dimensional data like voice and image and text. So all of the applications that you're seeing regarding object detection, feature extraction, for example, is most probably using deep learning. And in ArcGIS, we have 5 major capabilities. ArcGIS, as you know, is the flagship product for Esri. Esri is the world leader in GIS GIS platforms. ArcGIS is the product we ship. And you can find 5 main capabilities that serves machine learning and AI when it comes to geo. 3 of these have been classical. We have been having them in the platform for a while, and these are classifying aerial imagery, like classifying impervious surfaces, for example, and land cover, making predictions for geospatial events, and finding patterns in geospatial data clusters, for example. And recently, I've been investing in deep learning heavily for object detection, feature extraction, object classification, and land cover mapping, and natural language processing, dealing with highly unstructured data from text to extract meaningful insights. So with that said, I want to proceed with some use cases. The first use case is about predicting road crash risk. So this is one of the use cases that we pursue actively. And we try to focus on the use cases where we're trying to predict a geospatial event that is impacted by geospatial factors. So if you look at accidents, it's highly impacted by geospatial factors like weather, proximity to intersections, the number of lanes of the road, the curvature of the road, etc. So what we do is we get historical data for those variables, right, and the accidents that we want to predict. And then using different spatial analytics, we build predictive models that would predict the probability of having a road crash in the next hour on a specific road segment. And then using different capabilities in the platform, we can optimize resource allocation, like optimizing highway patrol allocation in real time so that we can proactively prevent accidents, right? So that's one use case. There are a lot of use cases in the area of computer vision. And as you know, deep learning is becoming very good in computer vision compared to classical computer vision techniques. So here we are detecting objects and features from incoming video streams from CCTVs. We are counting different car types, vehicle types, whether these are cars or buses or motorcycles. We are also counting pedestrians. This is easily achieved using some of the available frameworks like NVIDIA's Metropolis. We are partnering up with NVIDIA. They have an end-to-end video analytics engine called Metropolis, but then we're connecting this to our ecosystem through GeoEvent. So what's happening is per each intersection, we can train the model to detect different kinds of objects, as you can see, so that we understand the overall traffic patterns across the city. And then more importantly, we can understand the traffic anomalies. You see these 3 dots here? These are abnormal traffic events that we calculate on the fly by comparing the real-time behavior with the historical behavior. And this could be applied to anything, really. The rule is anything that you can see and detect as a human in 1 or 2 seconds, we can generally train AI to do it if we have good training data. So we have been using this with a lot of DOTs and smart cities to understand what's happening in the city, what are the abnormal events and stuff like that. Another use case is this, which is very similar to what my colleague has just mentioned, detecting road cracks. So we work with a lot of municipalities and DOTs who are interested in understanding the road infrastructure. And given the power of computer vision in deep learning, again, using a mounted camera on a vehicle, some vehicles would rotate the city and you would cheaply, in a cheap way, understand the amount of cracks per road segment and be able to overlay this on a dashboard like this. You can define the type of the crack, the depth, possibly the depth of the crack if you have some metadata. And once you bring this to the GIS, you can do different analytics with it, like where you should allocate your next infrastructure investment, for example. We are doing a lot of work in the area of LiDAR feature extraction. So if you're collecting LiDAR point cloud, we are working with cities and counties who are interested in detecting encroachments, for example. So oil and gas and utility companies are interested in understanding encroachments. So using some deep learning techniques, we can detect encroachments. And then we have street furniture like street lights and street signs. Others want to extract their assets. We're working with some rail companies who want to have an updated database of the location of all of their assets, like the road crossings and the mileposts, for example, and the crossings and the signals. So doing this and at the same time understanding with high accuracy the location of the asset requires LiDAR. In that case, there are some techniques like point CNN, which we have recently added to ArcGIS, that can extract this kind of features from LiDAR point cloud. We've been working with some local government as well on extracting road assets and features for road asset inspection from oblique imagery. So there are a lot of examples for doing work with overhead imagery, but then with oblique imagery, we can do stuff like extracting road assets like road signs. Some of the DOTs, for example, Department of Transportation, don't have an updated database of what exactly are the road signs, what is the type of each road sign, what's the text on each road sign. So we do this with different AI techniques. Some of them are computer vision, detecting the road sign and the type of the road sign, like it's an exit, for example. Some of them use natural language processing and OCR to detect the text on those road signs. And then you can have a beautiful dashboard like this with all of the assets. We've been working with some water companies to detect the water meters. As you can see here, this yellow thing is a water meter. So this pattern of, instead of sending a lot of engineers to the field to collect data manually, you can just fly drones or send cars with mounted cameras and then let the AI collect the assets for you and then bring this back to the GIS to do more analysis. As I mentioned, natural language processing is highly impacted by AI. So this is a crime report that you're seeing, working with police departments to extract crime insights from unstructured data. So as you know, data is generally structured and unstructured. This is a form of unstructured data. Someone is describing some crime, and then the AI would be able to extract the exact weapon, the specific time of the day, the specific location, etc., and then extract this with the lat long and the attributes, bring it to the map so that you can do more analysis. So I've been bringing some of those natural language processing capabilities in the platform because we know that a lot of our customers deal with such unstructured data. This is, again, classical. We've been working with a lot of national government and national mapping and statistics on automation of map production. So one customer in Kuwait used to have a team of 5 working for 4 hours a day for 1 year to have an accurate map of all of the road segments and building footprints across the country. Now with deep learning, we can automate this through in only 30 minutes. So can you imagine the amount of time we're saving here? So we're talking 5 human years down to 30 minutes with accuracy up to 96% in that case. And then following the same lines, we're doing high resolution land cover mapping, swimming pool detection, detecting of trees and assessing the health. And that's the power of doing AI in a GIS like ArcGIS. So you see this example here. This is not only detecting palm trees, but assessing the health of the palm trees. And assessing the health doesn't really happen by deep learning. We're using some of the raster functions, some of the indices like the triangular green index to infer the amount of nitrogen and chlorophyll in the leaves and hence infer the health. So combining this with powerful deep learning in a geospatial platform would help you do the end-to-end use case. This is a piece of work that we're proud of that we've been doing with Chicago Police Department using a specific kind of deep learning AI actually called reinforcement learning. So reinforcement learning does not really learn from historical data. It learns by trial and error. So the idea is it simulates the whole environment of the city and tries to make some actions and see what is the kind of reward on the long term that is generated by a specific sequence of actions. In this case, we're trying to optimize police patrol allocation in real time to proactively reduce the amount of violent crimes. We have found the relationship between the location of both patrols and crimes, and we have found that doing this optimization requires a prescriptive analytics engine. That's why we're using spatial statistics with reinforcement learning to optimize the allocation of those patrols, and it's showing really good progress, not only in police, but in transportation aspects. This idea of prescriptive geospatial analytics, if you will.
Hi, Omar. Can you please conclude it? Thank you.
What's that?
Can you please,
okay, cool.
Conclude the slides fast. Thank you.
So yeah, I mean, we have 3D building extraction from LiDAR as well, extracting 3D buildings. We have other capabilities, use cases like extracting blight and graffiti and overgrowth. In retail, actually, we're doing a lot of work by combining historical sales data with the competitor location and the customer store location to make predictions about best areas to open stores. And then the use cases are endless. What I really want to invite you to is to think of those possible use cases from your domain, whether they are in the area of computer vision or making predictions or finding patterns, because the capabilities are endless. And for that reason, we are building AI capabilities all across the board in ArcGIS in different products. So we don't think of it as a product, but as a capability that spans multiple products. Thank you so much.
Thank you for the introduction, and thank you for all the other speakers to set the floor very nicely. So it's well synchronized, and I'm happy to share some of our work with you and give some insights and background on what we are doing and why we are doing. A lot of our customers have what we call the GeoOps challenge. It's basically to bridge the gap between the static and the dynamic data. We do have on the static side a couple of classical tasks from geospatial, which are very often related to data production. And on the dynamic side, we do have, of course, the operational use on the one hand side. And on the other hand, we do have also a lot of sensors which pipe back a lot of information, which then needs to, again, captured by geospatial and the analytics there. And this pipe back of information is also very often done on our side with machine learning and artificial intelligence tools. When we are going to apply AI to our application or business processes, it's basically because we want to answer 4 different questions. One is basically what happened. We want to understand why it happened, and then we're going to look to the future and think about the prediction, what will happen and what should happen. And in order to do so, there's a couple of different technology used, from machine learning and artificial intelligence, and also pretty old, but nevertheless nice algorithms and algorithmics is working. And then we do a lot of very specific elements like change detection, object detection, classification, and segmentation. We do anomaly detection, for example, in AIS data streams. And we are also working a lot in predictive maintenance, obviously. With the predictive maintenance, I'm going to show you one example. That's basically a rail example after we had now the smart city and the digital twin for the smart city. And we had some road samples from the colleague from Esri. I'm lucky that I have chosen the track and the rail system. So most of the track operators are going to operate measurement trains or vehicles. That's more like one which is used in a first class operator, but this is also applicable to city light rail. And one of the elements they are interested in are what kind of substrate is the track based on, if it's gravel, if it's asphalt, if it's green grass. And they want to know about what is the material of sleepers, if these are concrete sleepers or wooden sleepers, because the knowledge about the sleeper gives you a good indicator about the maintenance cycles. And obviously in the next step, which we are currently on, we are training now to detect the crangles and missing balls and other things. The whole system is based on available still images, and it's completely integrated into a management system. Where all the data comes together for this light rail operator, and with our help and the AI technology, we have the possibility to, first of all, make all these pictures available on the fingertip into the system, into the processes. And the second one is also to improve the AI capabilities over time, because we implemented the technology in a process which is called typically active learning. That means you typically do have a kind of percentage of classification a certain image. And if you are in between a threshold, then the system cannot really value if this is a concrete sleeper or a wooden sleeper. And this needs some manual interaction, which is called then manual labeling. And these few sample pictures are then manually labeled by the engineer. And they are then used in the retraining of the deep learning algorithm. And so by its time, it's improving its capabilities of detecting the right material. The results are great. So we do have high detection rate for the substrate. Like here in this example, we have something like close to 99% of confidence that this is gravel. With sleepers, we do typically achieve something 80% plus confidence. It mostly depends on lighting condition. So if the sun is really very short over the horizon, sometimes you cannot really say if it's concrete or if it's a wooden sleeper. But if this happens, typically the human can't decide it either. The real key here is that previously we had a back office which was basically doing these analytics, and it couldn't really quote on each picture. So we had huge gaps on the track, and with this new approach, the whole track system is completely covered. It's directly linked to an LIS, so it's a complete coverage, and therefore the capability of predicting the maintenance process is significantly increased. Nevertheless, we're not only working on the still images, we're also working on point clouds, as the colleague already pointed out. We trained there some specific algorithms for detecting the signals, noise protection wall, and at the stations, the furnitures. And here we do not only classify the points, because the result will be a point cloud where you have thousands of classified points, which is great, which is a good first step. We are working towards a segmentation of these classified points, so that we directly detect objects which then can be linked to your asset management database and to BIM models to increase the quality of everything, of your complete infrastructure. However, in this project, what was the outcome for the authority? It improves reliability a lot. It was faster, whereby the question of performance is always a kind of a tricky thing. You can argue that these 10 minutes for 1,000 image is slow, which is okay, but it's still 20 times faster than the human. The key here is that these 10 minutes were reached on a regular PC. So no rocket science, no GPU enablement, no nothing. And the reason we were choosing a regular PC for this deep learning network and TensorFlow based was basically that this performance was already good enough for the customer. So we didn't overshoot the performance by increasing hardware costs. It's a very important element is to have the technology, but it needs to be integrated into the processes. Therefore, we integrated this AI part in a process so that it's really used on a daily basis. And finally, actually, it obviously helps to exploiting the existing data. Some more activities around Hexagon and AI. One of the main themes of Hexagon is really to be on the road of autonomy. It doesn't matter if it's autonomous cars, if it's autonomous rail, or autonomous other things. And within Hexagon, we do have the capabilities of the reality capture. We do have the ability of a lot of different software solutions, including our location intelligence. And then if you're going to fuse these things together, you are on the road towards autonomous technologies. One element of Zeus is reality capture. We do have a mobile mapping group, which does directly LiDAR and panoramic imagery on a really high quality base. And the real nice thing is that we already have AI-based automation in terms of clearance analytics and asset management. And one of our key topics of today is to bring this on the edge, that we do not store and move around too much the point cloud. Instead, we are working with the objects as soon as possible. We do have also content, the Hexagon content program. It's a cool program which covers Northern America and Europe. And it's the key here is it's really we're going to fly on a regular basis in high quality, and we can apply the same measurements all over this huge area. And one of the elements we bring in, it's not only the content per se, it's bringing in the analytics on top of that content. And this analytics is brought by the spatial modeler, where you can apply a TensorFlow-based mechanism to classify certain aspects. It goes further. We are having our major R&D initiative, which is called the XALT framework. And one of the key elements here is artificial intelligence and how to deploy it and what kind of model is appropriate for what kind of challenge, and combine this with edge computing. Our stepwise approach is very often we start small, we connect the devices, we connect the sensor, we connect the incoming data, we make pilot projects, and then scale fast and think big. And by that, I'm mostly done with my 7 minutes, and I thank you very much for your attention.
Good morning, good afternoon, good evening, as the case may be. Thank you very much for this opportunity to speak to you today. You know, as I was surveying and thinking about the different topics that might be covered on AI trends, I'm really glad to see the breadth that my colleagues covered. There are so many areas of development currently. And one that I find particularly interesting for field workflows is the emerging area of field robotics. These bio-inspired robots operate effectively in very diverse environments, and they can manage significant payloads for scanning, precision positioning, or environmental data gathering. They are currently playing a role in production and quality control workflows by enabling automation of routine, repetitive, or tedious tasks. But they're also ideally suited for operating in environments that are dangerous or difficult to access. And over time, we expect that they will extend the reach of GIS workflows while improving safety and productivity. I think another and very important trend, and in many ways we're witnessing it here in the discussions today, is the democratization of advanced AI and machine learning capabilities. With the right tools, training, data access, machine learning, and advanced analytics are increasingly in scope for technicians, analysts, academicians, and others whose primary background or job function is outside the field of statistics or data science. And in many ways, this follows the pattern of the last decade that brought business intelligence and descriptive analytics into the mainstream in businesses and other institutions around the globe. Trimble recognizes the importance of putting advanced analytics tools in the hands of those who can derive tremendous value when given the proper framework, support, and functionality. One such product is eCognition. Our industry is fundamentally about developing a deeper understanding of the physical world, the desire to extract information for the purpose of measuring features, tracking changes, or recognizing objects presented in an image or point cloud data set has traditionally been a complex multi-step manual process. That's where eCognition comes in. The central idea of eCognition is to transform data into information. From raster to vector, from pixels to objects, eCognition provides the tools and the framework to take control of the transformation process.
Sorry for sneaking in. I need to leave the building because we have a fire alarm. I return as soon as possible in case it's a training alarm. I'm sorry for that. For letting you know.
Take care.
Okay. Well, good luck. Yeah.
Thanks.
Okay. No fire alarms here. I'll keep going. So eCognition allows the user to bring together data from a wide variety of sources and seamlessly fuse, analyze, and render insights. This is the principal objective of eCognition's data fusion capability, which allows users to leverage the full potential of the data that's available. Once the data is brought together, method fusion allows the user to select and easily combine the best tools for mapping, bringing together machine learning, deep learning, and object-based image analysis. eCognition provides a robust tool set to perform different types of data analysis: knowledge-based, supervised and unsupervised classification, computer vision, and deep learning. These different methods are seamlessly fused within the rules engine, making it easy to combine different methodologies to obtain the best feature extraction in a single project environment. One of the methodologies that I appreciate as a data scientist is unsupervised classification, which analyzes imagery and clusters elements into groups at a pixel level. The algorithm determines how many clusters exist, and it automatically breaks these groups into individual classifications. That doesn't mean it will provide the complete answer, but it does provide an opportunity to gain new insights that might otherwise have been overlooked. It's fascinating to see these capabilities at work in the real world around us. Here are just two of many examples. Dr. Rolfsema's team goal is to create the world's first comprehensive map of the Great Barrier Reef's geomorphology, its seabed, ecology, and its specific coral types. And this extends across the 2,900 reefs that make up the Great Barrier Reef ecosystem. They're doing it with Trimble eCognition software. eCognition supports this, starting with data fusion to seamlessly combine satellite images with ancillary water data, both raster and vector. Then the team leverages sophisticated object-based image analysis tools to combine and optimize analysis methods, such as knowledge-based classification, with state-of-the-art machine learning and deep learning algorithms. It's a fantastic initiative. Our second use case involves some very important rocks. When we talk about the importance of rock glaciers, it's important to put that in context. And the context is between 2006 and 2016, it's estimated that mountain glaciers lost 335 gigatons of mass per year. That's 335 billion metric tons per year. The detection of rock glaciers is a complex process hampered by the spectral similarity between rock glaciers and surrounding material. As a result, the creation of these inventories, which are essential for understanding the water resource in arid and semi-arid environments, is conducted by manual interpretation, which is time-consuming and subjective. Recently, scientists engaged with Trimble to see if it was possible to leverage the high-resolution satellite imagery and the capabilities of eCognition developer software. The team chose convolutional neural networks to identify recurring patterns and textures and produce a prediction raster or heat map, where each pixel is assigned a probability that it belongs to a certain class. By using object-based image analysis, data sets are segmented and objects classified based on their heat map value, as well as morphological and spatial characteristics. I've included a link to the recently published study, and the results are very promising, even as the work is ongoing. In closing, I note that these are just two of many use cases that include urban monitoring, change detection of cadastral buildings, and humanitarian aid support. For more information, please visit the link on your screen. Thank you very much.
Training and education is provided to a larger client base and ensuring that the AI proliferation happens pretty quick. If you want to start with Benoit.
Yeah, I think there are some strong questions about IP usually and the sensitivity of the data. So depending on that, we can have different strategy to empower people, such as, you know, when we have strategy with open data, really accelerate the adoption of the technology by making the data open, and then the assessment of the ROI of AI on this is more straightforward. That's clearly things we see a lot in Europe these days with open data. Otherwise, when that kind of strategy is not possible due to the nature of the data, for example, what we do is we enable our users to, with the proper technology, so they can train themselves the AI to meet their specific needs, but they need more support then to tackle that challenges of really mastering how to train AI, which is not that trivial actually, because the impact of false positive or false negative during the training stages is quite important.
So one thing we focus on is try to democratize the experience as much as possible. So we believe the easier it gets in the hand of non-expert data scientists, the more adoption we're going to have. That's why we invest heavily in trying to abstract the complexities into easier layers to deal with. So, for example, we are trying to build push-button kind of experiences so that people who are not really writing code can do the end-to-end process of training and modeling and stuff like that and deploying these models to production. And we invest heavily in training programs as well. So a lot of times we find our customers willing to have like 2 or 3 day workshop to get their people up and running on these technologies. So that's one angle we focus on, is to try to build push-button kind of experiences and invest in training our customers and training the community on using these tools.
In Hexagon, we are moving more and more towards low-code or no-code environments, which is basically means, I think that was what a colleague from Esri said, you're going to move more like to drag-and-drop environments and easy to handle, easy to use environments. However, I see it's a kind of, on the one hand side, very exciting time, because the colleagues who are going to configure and use this stuff, they can focus on the algorithms. They can really focus on the mathematics, on the background, and how to make it happen. And they're not burdened by implementing things and compiling and coding things. So this is really cool and really nice. On the other hand, especially when we're talking about AI and deep learning, you need to understand that there's no one AI. Mm-hmm. So AI, we have a couple of executing frameworks like TensorFlow, which is most probably used by a lot of people. But then you're going to apply specific models on top of it, and these models have different capabilities and different KPIs. Some are easy to train, some are slow to train, some have a good positive false rate, and vice versa. And and a lot of them have different, so to say, elements to put a handle on. So what you basically need is a kind of consultancy work, which helps people choosing the right network and executing the training in a way that the result is reliable and meaningful to the customer. And this is not the, so it's either a very technical oriented way with these consulting stuff, and on the other hand, it's a really an enjoyable way when you're going to configure the things and configure the algorithms without necessarily implementing them.
Yeah, I think there have been some great points at which I would agree with. I think from our perspective, when you think about AI and data science, they're in some ways in a very simple model. You have this process of trying to bring together the essential data. And when we think about that, that's sort of this data fusion piece that I talked about. And then on the other side, you're trying to extract the information and from it, and that really gets into methodologies and this idea of method fusion. And so we try to organize the workflows in the same manner by which the data science, the data prep and the data science need to be conducted. And by making it modular and making it step by step, we seek to really simplify those workflows and ensure that our customers have highly repeatable, predictable, and reliable high quality outcomes. But I think that some of the other points made are really important. Sometimes, professional services engagements and other things can be part of that to help extend the reach. And I think the rise of citizen data science is really important, and I think we'll see this continue. But it doesn't eclipse the need for deep data science from time to time as well. It's sort of both. It's a bit of a hub and a spoke, and we're trying to support both ends.
Sure. One question before we go to the next session, which actually has an overlap, I believe. Ultimately, your users are mostly professionals and solution and services companies, right? So the question comes in saying that today a GIS analyst is doing certain tasks. There are larger teams working on data extraction projects. Would we lose our jobs into the future?
I mean, I think that's a famous question, as my colleague mentioned. I think it's going to automate a lot of the repetitive tasks, but then the more complex tasks that require more analysis, etc., are going to be still required by humans. So I would say it's going to even create more jobs that were not available before. But it's similar to any kind of technological disruption. If you think about electricity, for example, or any kind of the disrupting technologies, it did actually take out some jobs, but it did create more jobs on the other side that were not there. So I would say there's going to be more jobs related to analysis, because we're going to have more room for analysis, right? There's going to be less need to do the repetitive tasks and stuff like that. And the workforce, in my opinion, should be trained and equipped with what AI can bring to the table so that they are prepared for this age of automation, I would say.
I would like to add something to both colleagues. For sure, I see the same. It's more creating more jobs, but it's also creating different jobs than before, because with AI, we have the capability of processing more data in less time. On the other hand, we also need to understand that AI gives us a kind of probability. It's not a black or white answer, it's a probability. So we need the human in the loop very often to make the final judgment on do we need to act on it or not. And therefore, the human job will stay, will increase, but it will create and need higher educated persons at the end, because the dummy work, so to say, is already gone. It's covered by AI. And the meaningful jobs will increase. That would be my perspective on that.
I would echo a lot of what was already said. I guess maybe the analogy I would use is that we're entering an era where this proliferation of data and data sources, so we talked about bio-inspired robots, but we've got drones and we have all of these methods by which data can be gathered. And if you think of the repetitive tasks that can now start to be allocated to some of these resources, and then you can imagine these work opportunities where in some ways you move from doing kind of repetitive tasks to actually being more like an orchestra conductor that is managing a lot of different things. And so I think it will just change how we do work and open up new opportunities. And being a music guy, I really like the orchestra concept. I think that's very appealing in the long run. So take hope and heart. I think it's a really, really exciting future.